Boiling point. In this topic, we will discuss about the boiling point. There are lots of concepts behind the boiling points. I'll explain one by one each and every. Suppose what is boiling point? Suppose a water is taken in a container. This water, there is a water molecule, lots of water molecule which are strongly attracted by hydrogen bondings and other forces. They are strongly attracted. The strength between the water molecule is very high. What is the boiling point? Suppose this is a water. Suppose this is a water. For general, for general any water, the boiling points means in if we will provide temperature from the below. If we will provide temperature from the below, if we will provide 1 degree Celsius temperature, if it will become 1 degree Celsius temperature, it will become 2 degrees Celsius temperature, then go in increasing as the temperature go in increasing. At a temperature of 100 degrees Celsius, this water will boil. After the 100 degrees Celsius, this water become boil, and then after become a vapor after 100 degrees Celsius. So this liquid become a vapor. So what is happening? The two water molecules, suppose this water molecule is there is a strong forces, that's why this is in a liquid state. After giving the energy as a heat, we are giving heat as a energy. The strength between the forces between these two water molecules break, and this become from liquid state to a vapor state, means two molecules are very much near, that's why this is a liquid. After it become vapor, the water molecules go in very long distance, so now this become a vapor. So what is boiling point? Boiling point is the temperature at which the liquid state, yeah, any other state become vapor. Any other state become vapor, solid state become vapor, actually liquid state become vapor is a boiling point. When so this liquid state become vapor, this is a boiling point. When solid state become a liquid, this is a melting point. Now liquid become a solid, this is a freezing point. So this thing need to be take care. So now it is clear the temperature at which the liquid become vapor, this is called boiling point. Boiling in a so the boiling point is a temperature energy required to break the strength between the molecule, which is the break the strength, the break the force which is held between the two molecules to make them liquid. So in this way, now we will learn all the things I have explained. Now this is in the proper format written. Now we learn this thing. The boiling point of a compound is the temperature at which the liquid from the compound become gas. Now this is clear. Liquid become gas. In order for a compound to vaporize, the force that hold the individual molecules close to each other in a liquid must to overcome. So the force which hold the molecules, this force, we have to overcome this force by providing the energy to break this force and make them water molecule or liquid state to a vapor state. This means that boiling point of a compound depends upon the strength of attractive force between the individual molecules. Attractive force between the individual molecules. If there is a more attractive force, this is a, suppose water, there is a some attractive force. That's why there is 100 degrees Celsius. But in the transformer, as you know, all you know the transformer, there is a one coolant is used. Coolant is a one type of liquid which is very cold. Cold means their boiling point is very much high. So if the transformer become hot if by the heat, transformer become hot, but by the coolant we keep the transformer in minimum temperature. Why we are how they are keeping the minimum temperature? By the coolant is having very high boiling points, means they require very 200 degrees 300 degrees as per as the requirement degree Celsius temperature required to make them boil. It will remain in the liquid state to make them stable. Transformer doesn't become very much heat by using the coolant. So some type of liquid, there are different type of liquid which having some liquid having 120 degrees Celsius boiling point. At 120 degrees they start to boil. Some compounds having 300 degrees Celsius temperature. This type of temperature required to boil the compound. So this is how this is temperature increasing, the boiling point increasing, the strength of force. As the strength of force between the molecules of liquid increases, the boiling point increases. This type of plants which is very used in transformer, as the strength of the attraction force increases, the boiling point increases. So if the molecule are held together by a strong force, it will take a lot of energy to pull the molecule away from each other, and the compound will have a high boiling point. This thing I've already explained. In contrast, if the molecules are held together by a weak force, only small amount of energy needed to pull the molecule away from each other, the compound will have a low boiling points. So the relative amount, the strength of force will decide the boiling point. How much the strength of force, that will define the boiling point. Such as this is a carbon chain is there, 1 2 3 4. Such this three, one thing I'll make clear, less than 3 carbon, less than 4 carbon is a gas format. Less than any carbon at room temperature remain in the gas form. 5 carbon will be in the liquid form at a temperature, this will be in the liquid form, and greater than the 5 carbon will be in the solid form. Generally in this form at room temperature they were found. So the alkane molecules are held together to make them liquid, to make them solid. There is a strong force is required. Now we learn something definition, then I will make clear. Relative weak force are hold alkane molecule together. Alkane contain only carbon and hydrogens because of the electronegativity of carbon hydrogens. In alkane there is a hydrogen is there. There is an electronegative difference between the carbon hydrogen is approximately 0. There is no much electronic difference, so there is no any partial negative, partial positive charge. There is no any development of such charge is there. As the HCl, suppose HCl molecule is there, there is a del minus del plus charge is developed because there is a lots of electronegative differences there. There is a high electronegative differences there. That's why there is a development of plus and negative charge, plus minus partial charge. But in carbon hydrogen there is a very less electronegative difference. That's why there is a very less development of negative and positive partial negative charge. So there is a no significant development of partial negative and positive charge. But as these are in chain. In at some instance there is a slightly difference in the electron clouds. At some instance electrons are moving continuously, electrons are continuously moving, so at some point of time there is some shift of electrons. In either side there is more electrons, in other side there is less electrons. So at any instant the electron density on one side of the molecule can slightly higher than the on the other side, giving a molecule a temporary dipole. Suppose there is a hydrogen is there, here is a hydrogen is there, here is a hydrogen is there, here is hydrogen is there. So this will be in this format. Maybe in some point of time electrons are keep moving surrounding in orbital, so there is maybe slightly shift of electron in one side, it will increase the density of electron in one side, in other side there is a decrease in density. At any instant there will be, so there is a temporarily a dipole moment will be generated, del minus del plus, del minus del plus. This will be slightly charged, del minus del plus, and this will be temporarily develop. At any instant they temporarily develop. So this will develop in del minus del plus, del minus del plus, del minus del plus. In this way there is a development, and this del plus del minus will attract, del minus del plus will attract, this will attract, other charges will be attracted. So in this way there is attractions, the opposite charge will attract. As in the similar way there is a partially positive negative charge is there in the adjacent orbital, so it will attract. Now it is attracting in this way. If there is more than 4 carbon is there, 5 carbon is there, so they by this attractions for they will be in a liquid form. If more than 5 carbon will be there, then they will be in the solid form. Similarly, this is the force of attractions between the molecules. Now our next thing, a temporary dipole in the molecule can induce a temporary dipole in the nearby molecules. As a result, negative side of one molecule will adjacent positive side of another molecule, as shown in the figure above. As there is a temporary dipole, this is a temporary dipole is developed. This will induce a temporary dipole. This is a temporary dipole is developed. Similarly, there is a temporary dipole, some amount of charge. After this inducement or some amount of charge, the overall del minus will be developed. So in this way there is a development. Not only this will develop, this will attract not. This will also develop some amount of charge develop, some amount of for the inductions, some amount of charge develop. So overall del minus and del plus is there. So there is attractions between these opposite charges. As in the Coulomb's law, there is attractions to the dipole attractions is there. So in this way there is attractions. Now this same thing is written. And because the dipole in the molecule are induced, and attractions between the molecule are called induced dipole attractions. The molecule of alkane are held together by a induced dipole interactions, which are known as van der Waals forces. Van der Waals forces are the weakest of all the intermolecular forces. There are some different types of intermolecular forces. Van der Waals forces are the weakest forces. This is the induced dipole attraction. This type of attraction is called the induced type of attractions. As these are the induced in some instance of time. These are the induced dipole. So this is called induced dipole attraction between this alkane. Now these are the this thing clear. In order to alkane to boil, the van der Waals forces must overcome. To boil must overcome. The magnitude of van der Waals forces that hold the alkane molecule together depend upon the area of contact between the molecule. The greater the area of contact, the stronger are the van der Waals forces, and greater is the amount of energy needed to overcome these factors. If you look at the homologous series of alkane, you will see that the boiling point of alkane increases as the size increases. This relationship hold because each additional methyl group has increased the area of contact between the molecule. The four smallest alkane have a boiling point below room temperature. This thing I have already explained. As there is a this van der Waals forces increases as the area of contact increases. This area of contact increases, van der Waals forces increases. So if 5 carbon will come, if this another 5 carbon will come, then there is a more area of contact. If 6 carbon will come, there is a more area of contact. As the area of contact increases, van der Waals forces increases. So the gas become liquid become gas. So there is a 4 carbon less area, 5 carbon. This is a 5 carbon total overall area increases. So van der Waals forces increases. If the more than 5 carbon is there, 6 carbon, more area increases, van der Waals forces increases. So the gas become solid. So this attractions, as the attractions increases, van der Waals forces increases, and as the gas become liquid become gas. So this thing I will explain that as the number of carbon increases, surface area increases, van der Waals forces increases, boiling point increases. But here is all the, if we count the number of carbon atoms between these three compounds, the carbon atoms are same: 1, 2, 3, 4, 5, 5, 5, 5. All the compounds have 5 carbon atoms. The molecular formula is same, molecular weight is same. So, but this compound have a less boiling point than this compound. As the branching increases, as this compound has a one branching, this compound two branching. As the branching increases, then the surface area decreases. So van der Waals forces decreases, boiling point decreases. That's why this compound have higher boiling point, 33 degree, 36.1 degree Celsius, 27.9, 9.5. So as the branching increases, so this thing need to be named branching increases, surface area decreases, van der Waals forces decreases, boiling point decreases. Now similarly this here in a carbon and hydrogen there is approximately no much electronegativity difference. So approximately there is a very less electronegativity difference. So there is no any charges will be developed. So if any molecules polarity will be developed, this many molecule polarity will be developed. Polarity is how developed? Suppose this hydrogen is there, hydrogen is replaced by a halogen. If halogen will be there, then the halogen has high electronegativity. That's why this will be developed del minus and del plus charge develops. As the polarity will develop, there is a more attraction force in this bond. This bond has a more attraction force. As the attraction force increases, we have more energy required to break this bond. As the energy required to break the bonds increases, the boiling point increases. Boiling point, what is boiling point? Boiling point is the energy required to break a bond, to break them free to vaporize. So as this is polarity is developed, so there is a more attractions, more dipole moments. So the strength increases. Is this bond? Strength increases. So boiling point increases. In this way, all this compound having some things, chlorine and hydrogen is there. This will form hydrogen bonding also. Hydrogen bonding was one type of attraction force. Attractions increases means strength increases. Attractions increases, strength increases. The strength increases where there is more energy required to break this strength. So boiling point increases. In this way we can learn if any compounds there is a formation of dipole, the dipole formation, then dipoles, this plus minus dipole, so many molecules there, dipole is formed. This plus minus will attract, they will align in one direction. As there will align in all directions, there is attraction, so finally they will align in one direction. As there is align in one direction, so a stronger the van der Waals forces, they will, if align in one direction, there is a stronger van der Waals forces. So as I have already told you that if a carbon chain is there, this is a 4 carbon chain, but this is a branching increases, surface area decreases, so boiling point decreases because van der Waals force decreases. In this there is a greater surface area For the attractions van der Waals forces, so this is a boiling point increases. Similarly, these are the arranged in very disorder. So actually in this way there is a, we can say there is a branching, lots of branching format. So the boiling point is less, but there is a attractions between this dipole, opposite dipoles. So this will align in one direction. As the alignment increases, surface area increases, van der Waals forces increases, van der Waals forces increases, boiling point increases. And van der Waals forces are strong forces, but not as the strong as the ionic forces and covalent forces. Van der Waals forces are the weakest intermolecular forces, and the van der Waals forces is very less than the strong, not as strong as ionic forces and covalent forces. There is a cyclopentane and tetrahydrofuran. These are having the same structure, but this having a higher boiling point than this. Why this is a more boiling point? There is a oxygen is there, very electronegative atoms. This will generate a polarity in the molecule. This will induce a dipole attractions will develop in the molecules. If 2 3 4 carbon, if for this we have to check in some amount. We didn't check 1 2 3 1 this compound, 1 this compound. In the solution we are checking how much this is boiling point, how much this boiling point. We are solution in taking. Solution means some amount, maybe 10 5 20 50, 10 5 20 50. We have taking some amount of this, some amount of this. In a container we have taken some amount of this. In a container we have taken some amount of this. So to check in this format. So this has a the electronegative atoms, oxygen. This is having electronegative atom. This will produce a dipole attractions in a solution. So it will increase the attractions for, it will increase the strength between the compound. So it will increase the boiling point. In such of examples, this having doesn't having any group, this having oxygen, this will produce dipole interactions. The oxygen higher electronegativity, oxygen and hydrogen is there. This is a 9NH2 is there. This will produce 2 hydrogen bonding. This will produce 1 hydrogen bonding. This having oxygen is it will produce dipole interactions. It doesn't having any dipole moment. So we are thinking that this compound which must be higher boiling point than this, and this compound must be higher boiling point than this, and this compound should be higher boiling point than this. That's one thing is here. But this compound boiling point is less than this compound. Why this compound have a less boiling point than this compound? The reason is that this is a O and S there. There is a, as the this as much this polarity is there, as much greater the charge will be there, the more stronger hydrogens bomb will form. This oxygen has a more electronegativity than the nitrogen. Nitrogen has also H, and nitrogen has also has a H. As this nitrogen is less electronegative than the oxygen. Oxygen nitrogen electronegative difference is very much higher than the nitrogen hydrogen electronegative difference. So the del plus charge will be developed from here. Here is also del plus and del minus charge will be developed, but this del plus del minus charge will be less than the oxygen and hydrogen, because oxygen is higher electronegative than the nitrogen. So there is a greater difference between electronegativity than this, greater electronegative difference. That's why it will also produce hydrogen bonding. It will also produce hydrogen bonding, but this hydrogen bonding will be more strength than this hydrogen bonding. This compound hydrogen bonding will be having a more strength than this compound hydrogen bonding. That's why this compound have a higher boiling point than this compound. But if you to consider the amine, if 1 degree amine, 2 degree amine, 3 degree amine is there, 1 degree amine has a 2 hydrogens for hydrogen bonding. 2 degree amine is having 1 hydrogens for hydrogen bonding. 3 degree amine doesn't having hydrogens, so it will having higher boiling point than this. So in this way you can compare. But for oxygen and nitrogen is there, oxygen have a higher electronegativity. That's why this should be having higher strength of hydrogen bonding. So that's why this having higher boiling point. Similarly, this compound having oxygen, this compound having hydrogen, this having NH2. That's why this is a higher boiling point than this compound should be lower boiling point than this. So in this way you can compare. Also this same molecular formula means same molecular weight compound. So in this way we can compare the dipole moment. So this case need to be remember the hydrogens. So in this way the students is generally confused. There is a hydrogen bonding, so attractions increases. In this way there is a lots of group are in the hydrogen bonding, so the attractions increases, van der Waals forces increases, surface area increases, van der Waals forces increases, attractions increases, hydrogens bonding, so the boiling point increases. So in this way we can explain the hydrogens bonding increase. So this is in the solution there is some compound. In the solution we are putting some compound. So some compound means if some compound is putting, if there is a hydrogen there, then there will be hydrogen bonding forming between the compound. There is a formation of hydrogen bonding, so it will increase the strength of attractions between overall molecules. The attractions increases, that's why the boiling point increases. So in this we can give the example, this compound having the nitrogens, so in this way there is also attractions, fluorine also having attractions. So as the attractions increases, overall compound attractions increases, boiling point increases. Attractions increases means strength increases, bond strength increases, boiling point increases. Here is a 1 degree amine, primary amine, secondary amine, tertiary amine. Tertiary amine doesn't having any hydrogens to form a hydrogen bonding. It is having one hydrogens for forming hydrogen bonding. One hydrogen bonding. This compound having two hydrogens to form two hydrogens bonding. That's why this is higher boiling point than this, than this. In this way we can compare the boiling point. Here is also such a three hydrogens bonding, two hydrogens bonding. This will be greater. Now to this NS2 will be lesser hydrogens bonding, because N have a lesser electronegative difference between OH. This OH will be higher electronic difference, that's why this will be having lower boiling point. In this way you can compare. This group doesn't having anything, so it will be lesser boiling point as a polarizability. Now to see in this type of compound, as there is the iodine, bromine, chlorine, fluorine, hydrogens. Iodine has higher, bigger size than the bromine, fluorine, and hydrogens. Fluorine, chlorine, bromine, and hydrogens, they are in a group. So in a group, you have to generally consider the size. Size is the main factor in the group, and in a period there is a more factor of electronegativity. So this is size factor. So boiling point, you have to consider the size. In a boiling point, you have to consider the size. Here I have written in this text the as the halogen atom increases in size of electron cloud increases. As a result, both van der Waals contact in an area and polarizability of the electron increases. Polarizability indicates the how readily an electron's cloud can distorted. So as there is a size increases, there is a electron cloud is there in the bigger volume, bigger size of this orbitals, bigger size of orbitals, electron is there, so there is a more area for the distortion, decoalization. There is a more area of this electron, and there is a more area of decoalization, so area of contact increases, surface area increases, so van der Waals forces increases. Van der Waals forces is the main factor for the boiling point, so this van der Waals forces depend on the area of contact. So area of contact increases, this size increases, orbital increases, this electron clouds more decolized, and van der Waals forces increases, surface area increases, so the boiling point increases. So in this way, this having less boiling point than this, so the increasing order boiling point will be, this iodine will be higher boiling point than this is, so bromine will be higher boiling point than the chlorine will be higher boiling point than fluorine and hydrogen. So for the normal process, here for normal we were simply thinking that there is a fluorine is there, fluorine is high electronegativity, the bond strength should be higher, boiling point should be higher, but this will be wrong. We have to consider the size. The size is the main factor. In the group, we have to consider the size, and in the period, we have to consider the electronegative. This the idea need to be take care. This thing is the main need to be remember. So this size increases, electron cloud will more decolize, and surface area increases for the van der Waals forces attractions, and boiling point increases. Now I'll explain what is the general trend that affect the boiling point. A strength of intermolecular forces. So as the number of alkane increases, there is a number of alkane increases, the van der Waals forces increases. But intermolecular forces, there is nothing is there in this compound. Oxygen is there to form a dipole attractions. This compound having hydrogen is there to form hydrogen bonding. This compound having oxygen minus nitrogen and sodium plus. This will be the ionic bond. This binding bond is the strongest bond. Ionic bond is the strongest bond. This compound having ionic bond, this having hydrogen bond, this having dipole interactions, this having van der Waals forces, dispersion forces. So this will be higher boiling point than this, and this dipole will be weaker than the hydrogen bonding. Hydrogen bonding will be weaker than the ionic. So this the forces strength increases, boiling point increases. That's why this having higher boiling point than this, and this compound is shown approximately similar boiling point, but if any examinations questions are we have to compare, then this will be higher boiling point than this and this. In this way we can compare, but actually this is experimental data. But in objective type examinations, if no any such type of data is given, then we have to compare If you have to give answer one is higher boiling point than the other, then this will be higher boiling point than this. This is a molecular weight. This is a molecular weight is given. This is a boiling point is given. Mistakes by the mistake. This is having higher boiling point than this, then this. In this way, the boiling point will be higher. The length of carbon, as the length of carbon increases, when the process increases, this is having higher length of carbon, So the length of carbon increases, boiling point increases. So this way, the boiling point is shown. This is having higher boiling point than this. As this is having similar thing, consider the boiling alcohol is there. This will form hydrogen bonding. So this similar type of group, as a this increases, boiling point increases. Similar thing is shown in all the examples. As this group is increases, when the process increases, so the boiling point increases. Similar thing is shown in this group, as the number of carbon increases. Branching increases when the forces decreases, and boiling point decreases. As the surface area decreases, boiling point will be decreases. This is a greater area, this is less area. As the branching increases, boiling point decreases. This thing, all thing I have already explained. Only I making much clear. The branching increases when the process decreases, boiling point decreases. This thing, all thing I have written. As the polarity increases, boiling point increases. So now there are four intermolecular forces, how they affect the boiling point. Now I'll explain these things. There is generally four intermolecular forces are there, and they are affecting the boiling point. So I'll explain one by one the four important intermolecular forces. First of all, I will explain the little bit introductions about there. It is amazing how much chemistry come to simple attractions between the opposite charges, repulsion between the like charges. This is very simple. Opposite charges are attracting, plus minus will attract, plus will repel, minus will repel. This is driving force behind the chemical bonding. This is the chemical bonding driving force of plus minus other attractions, repulsions, of course, but it is also responsible for the force between the molecules. This attractions force is also responsible for the force between the molecules. This means that the properties like melting point, boiling point also measure how strong the attracting force are between the individual molecules. These are the melting point, boiling point. What is the melting point, boiling point? How much the melting point, boiling points? That depends on the strength of bonds. A strength of bond, how decided? The attractions. If the greater will be the attractions, greater will be the strength, greater will be the boiling point, melting point will be. So these are the factors which will decide the such type of physical chemical properties, the attractions, repulsions, forces. There are four types of these interactions, and they are different manifestation of the opposite charge attractions. So these are the we can basic is there the attractions, repulsions. These are forces will explain what is attractions in terms of organic chemistry. It all follows the general principle. All the bonds become more polarized. The charge on the atoms become greater, which lead to greater intermolecular attractions, which leads to higher boiling point. So this is the basic. So ionic bond is there, hydrogen bond is there, van der Waals dipole interactions there, van der Waals forces there. These are the main things there. This is the higher, this having higher intermolecular forces. This is the higher strength than this and this. Van der Waals dispersion forces come in the last. So we look only one by one. This is ionic forces. What is the ionic forces? Ionic forces and attractions between the charge atom and molecule. There are attractions between the charge atoms molecules such as sodium chloride. There is a charge molecule. This will be a plus, this will be minus. Such type of interactions between charge molecule, positive charge ion such as sodium, lithium, calcium, atom as cation, negative charge anion, chlorine, bromine, OH are called anion. I always go the straight through the remembering that the nitrogen's anion stood for negative. The attraction force between the opposite charge ion described by Coulomb's law, in which the force increases with the charge and decreases with the distance between this anion increases. So this is the similar to the ionic force, similar to the Coulomb's law. Coulomb's law K1 K2 by R square. As the charge increases, attractions increases, and distance increases, attractions decreases. If distance increases, this overall will be the force will be decreases. Force will be decreases. If this will be decreases, then the force will be increases. So this way there is explained, there is ionic forces will be there. So now we learn about the hydrogen bonding. Hydrogen bonding simply, then there is a hydrogens there, then there will be hydrogen bonding will be formed when this is attached with the more electronegative atoms. As that electronegative atoms, this electronegativity increases, the plus charge will be increases, so it will form a more and more hydrogen bonding. As the hydrogen bonding is attraction force, it will make them compound more strongly bonded, and boiling point in this way increases. So this is in this way there is a formation of hydrogen bonding between the compounds, and this H of one molecule, O of another molecule, H of one molecule, N of another molecule will combine and form a hydrogen bonding. In this way there is an increase in the boiling point because the strength of this compound increases. So the van der Waals dipole interactions, when there is a more electron atoms is there, it will develop del minus and del plus will develop. There is a dipole interaction is there. Similarly, there is a minus del minus will develop. Here del plus will develop due to this. Here oxygen is there. It will become del minus, del plus will be there. There is attractions between the dipole. So this is called a dipole interactions. This dipole interactions also increase the strength of bond. It will also increase the boiling point. Fluorine will be develop del minus, it will develop del plus. The similar things will develop del minus, del plus, del minus, del plus will be developed, and this will increase the boiling point of compound. And van der Waals and dispersion forces, London forces. Van der Waals dispersion and London forces in any bigger size atoms, there is electron clouds are surrounded by these atoms, but any extent of time, some electron cloud will be more in one side and less will be electron cloud in one side. So there is a dipole will be developed. This dipole will be indicated like this. This is a more electronegative atom, so this will be arrow is shown, and less electronegative. This less electron will be there. This will be shown as a plus. But this way this can also be shown. Del minus del plus can be shown. This is electron deficient. This is excess of electron on one side. There is a instantaneous dipole is produced. In this compound, instantaneous dipole is produced. Instantaneous dipole is produced. I have written some theory. The weakest intermolecular forces are called dispersion forces, London forces, that represent the attractive force between the instantaneous dipole in the molecule. Instantaneous dipole is for this. This is also called van der Waals dispersion forces. This is instantaneous developed, not permanently. They are instantaneous for sometimes. This type of dipole is produced, and this will increase the attractions between the atoms. In this way they will affect the boiling point of a compound. The bottom line is there, the strength of forces will be, any compound will be higher strength. If anywhere any compound will be there, then that will be higher boiling point than the hydrogen bonding dipole and dispersion forces. All things I have already explained, and little bit more about the boiling point. This is the boiling points. This will be higher boiling point. This thing I have already explained. The bigger the size of halogens, greater will be the boiling point. But in the fluorine case, there is some exception is there. This having higher boiling point. 2 fluorine will be higher boiling point than the 1 fluorine and then the 3 fluorine. Actually, this order will be 1, 2, 3, 4, because this is minus 25. This minus 25 should be here. So this 2 fluorine, this is an exception. In examinations, there is some confusion may be there by this. Make this example. So 2 fluorine will become when it helpful, right? This type of compound will be there, and then this will be higher boiling point. This will be higher boiling point. This need to be take care. 2 fluorine, 1 fluorine, then 3 fluorine, 4 fluorine will be there. So in this way there is a, but in the chlorine case that will be simple. This will be, as the chlorine increases, boiling point increases. But in the fluorine case, this is a exception is there. This is a one exception I am telling you. This need to be remembered. The 3 tend to affect the boiling point. I am summarizing all the things, whatever thing I have make you understand about the boiling point. I will make you clear. The relative strength of 4 intermolecular forces. As the relative strength, there is ionic forces. This is the hydrogen bonding. This is dipole attractions. So this will be more stronger than this. So the boiling point will be higher of this compound. This compound should be higher boiling point than this. All intermolecular forces we have to keep in mind. This is a higher boiling point than this having hydrogen bonding, this having ionic bond, hydrogen bonding, dipole. This should be a higher boiling point than the other. Similar things happening in this compound also. There is ionic bonds, there is hydrogen bonding, dipole interactions. The functional group also affect the boiling point, and this is a higher van der Waals forces. As the surface area increases, van der Waals forces increases, boiling point increases. In this way also there is an increase in the boiling point. All the things I am summarizing. The similar things Symmetry. As the symmetry increases, branching increases, boiling point decreases. Why? Yes, decrease in surface area, so this is why there is a decrease in boiling point. Similarly, this compound also, there is the branching increases, the boiling point decreases. This is a 137 degree, this is a 115 degree Celsius. So I am summarizing overall thing. I am summarizing hydrogen bonding. Intermolecular hydrogen bonding increases, boiling point increases. Intramolecular hydrogen bondings will be there, boiling point decreases. Intramolecules and intermolecules between the molecules, and intermolecular means in molecules. In same compound there is a hydrogen bonding will be there. Molecular mass increases, boiling point increases. Dipole moment increases, boiling point increases. Surface area increases, boiling point increases. This is boiling point increases, and branching increases, boiling point decreases. So this way, now this is some trend need to be remember. This is having higher boiling point than this, and then this need to be remember. The order is need to be remember. This having higher boiling point. This one this need to be remember. This will be having higher boiling point. So this order need to be remember. In examinations, it will be very useful to remember. So in this way, I'm summarize all the boiling point. This order is very much important. So which compound is higher boiling point? This order need to be remembered. And now we will learn about the melting point.